Let's do a quick recap of what we have learned about Docker images. It is the executable version of application and contains all of its dependencies. It is the build part of the containerization cycle, and the image is the stuff that gets shipped to the actual production site. It is a read-only template with instructions for running a Docker container. Images are the building blocks from which we launch containers. When a new container is created from an image, a writable layer is also created. This layer is called the container layer, and it hosts all the changes made to the running container. This layer can store newly written files, modifications to existing files, and newly deleted files. Repository holds images. So for example, MongoDB is a repository, Tomcat is a repository, and so on and so forth. Each repository generally holds multiple images which are identified by the tag associated with it. If we don't specify a tag, then the latest image from the repository is selected. A registry holds the repositories. Docker Hub is a registry. We can also configure our own registry, which we'll cover in the later modules of this course. Let's understand the layered file system of the images. A Docker image is made up of file system layered over each other. As we have seen earlier, it uses UnionFS as file system service. It allows several file systems to be mounted one over the other but appear to be one file system. The resulting file system contains files and subdirectories from any or all of the underlying file systems. Docker calls each of these file systems images. Images can be layered on top of one another. Any update on the image adds a new layer instead of rebuilding the entire image. The image below is called the parent image, and you can traverse each layer until you reach the bottom of the image stack where the final image is present, which is called the base image. Each layer except the topmost one is read-only. In the diagram here on the screen, we can see that the Debian works as the base image, which is the parent for the OpenJDK, which in turn is parent for the Tomcat image. Okay. So finally, when a container is launched from an image, Docker mounts a read-write file system on top of the layers below. This is where whatever processes we want our Docker containers to run will execute. This layer is often called the container layer. All changes made to the running container, such as writing new files, modifying existing files, and deleting files, are returned to this thin writable container layer. Hello everyone. In this nugget, we will learn how to use CLI commands with Docker images. Okay, so let's go back to our host and we will see these commands. For listing the images, we can either use Docker images, okay, or we can also use Docker image ls. So Docker image ls, it will give you the similar kind of a result. We can further provide options like --no trunk to list the full length of image IDs. So if you want to, now whatever information is displayed here, if you want to look the full length of image IDs, then we use this command with no trunk option. So as you can see, you see the entire image IDs in here. The output of the command Docker images or Docker image ls can further be filtered. Let's say I want just to see the images which were created before or after a particular image ID. So I will first do a Docker image ls. So it can be done with the command Docker image ls, and then we can use the filter command on top of that. Right. So let's go back now to the host and use this filter command out here. So if I say Docker image ls, that will just give me all the images here. Now if I say, if I want to see before this image ID, then I would say Docker image ls -- filter, in the double quotes I would give before equals to the image ID which I am referring to here. Okay, so it will only give me the image IDs for the images which were created before this particular image, which I have given image ID of. Similarly, if I want to list the images which were created after this image, then we can use the since option. So let's go back here, and instead of before, I would just give the since out here. So it gives me the image IDs for the images which were created after this particular image. Okay, so this way. Same command can be run with Docker images command as well. Docker images command as well. So let's do a quick check for the previous command. It will run it with the Docker images instead of Docker image ls. Okay, that also works. There is the concept of dangling images also. There's a concept of dangling images which is kind of important to understand. Dangling images means that you have created the new image, but instead of giving it a new name, the image was created again with the same name which existed already. So the older image becomes the dangling image. That is, it cannot be accessed anymore by the repository name and the tag. Such old images are displayed as none on their repository name. Okay, so I have created one for our session. So let's go back to our host. If we just want to run command to list the dangling images, it can be done with the command docker image ls --filter, and then in the quotes we will give dangling equals to true. Okay, so hit enter. It will just give me the result of the images, which is dangling image, as you can see here. The formatting action, which is provided by the formatting option is provided by the format pretty prints container output as per the Go template. Okay, if you just run docker image ls, we get the output in columns as repository. Okay, let's clean it a bit. You get the output and in columns as repository, tag, image ID, created, and size. If you just want to list the images with output in only two columns, let's say of ID and the repository, then we can fine tune the output display by using this format. So let's do that now. Docker images, docker image ls. Instead of that, we'll use docker image ls -- format. It has a very peculiar syntax, so just pay attention to this syntax. .id colon and the repository. Okay, close the brackets and close the double quotes. Hit enter. It gives me the output as the image ID followed by the name of the repository, as can be seen here. We can use the same command with docker image as well. So let's have a look. Now docker rmi or docker image rm are the docker commands to remove one or more images. You can delete multiple images simultaneously through a single command. So let's run a docker image ls to note the available images that we have on our host. So let's get back here. Docker image ls. We already have the images, latest images of Ubuntu, Nginx, Tomcat, and Redis. So let's delete the images for Tomcat, Ubuntu, and MongoDB. Okay, so let's go ahead. Let's do a docker image rm, and we will do it for MongoDB latest image. I'll use the image ID for this MongoDB. We can delete images for Ubuntu. I will use the tag that I have here. Okay, and for Tomcat, I just want to delete the latest image, so I would not mention anything else but Tomcat. Now let's list the images. It has executed successfully. Now let's list the images here. Docker image ls. No, it should be docker space image ls. So all the three images got deleted successfully, as we can't see them anymore here. From one of the images in the system, let's run a container. We will not use the -rm option now. So, okay. So we'll use it for Redis. Docker run. Okay, so Docker run -itd Redis. It will take the latest image for the Redis. Okay, so the container is started. Let's check its using the PS. Okay, so as it is up in the up stage. Let's try to remove the image now. So Docker image rm Redis, as we are using for Redis. If the container is using an image, then that image cannot be deleted. That's why we are seeing this error out here. So we will first have to stop it. So let's stop the container by using the docker stop command. So we'll first stop the container and then we will try to run this again. So docker stop the image ID. Okay. So let's check it using the ps command again. It's in stop stage now, as you can see here. So let's try to remove it again now. Okay, so let's try this command again, docker image rm Redis. It is still giving me the error. I'm still not able to remove the image because the container still exists, which is using this image. So if the container, whether in running stage or stop stage, is using an image, then that image cannot be deleted.